Okay, this is lesson 4C, and as I alluded to in the last lesson, 3C, that there are some problems with solving a system of equations by graphing. And here are some examples. So in this one right here, example A, graphing can be difficult if you have very large numbers. So your x and y intercepts and your points of intersection are going to be very large numbers and going to be difficult to find a graph that will support that, unless you're on a graphing calculator. Example B, if you have decimal values, then that's going to be difficult to graph, and possibly the solution will not be whole number values. And problem C, even with some graphing calculators, you will not be able to graph this. So if you have a TI-84, TI-83, you can graph anything that starts with y equals, but they will not graph x equals 8. So we're going to learn how to solve those using substitution. So let's start with this one. So using substitution, keep in mind that both of these are lines. This is a line, even though your TI-84 or TI-83 will not graph this line is a vertical line, x equals 8, out here like this, okay? And then this other line in slope-intercept form, it does have a large negative y-intercept, and so it's going to be down here and have a negative slope. And so the intersection point is going to be off of your normal 10 by 10 graph. But what we do know about the point of intersection is that it has to be on this vertical line, and this vertical line has an equation of x equals 8. So all of the points on that line have the x value of 8. So same with this point right here, the x value is 8, we just don't know what the y value is. So what we're doing really is we're taking this x value of 8 and we're putting it into this equation over here to find the y value. Basically, that is what substitution is. So we're taking a value that we know and putting it in place of the variable. So we know the value of x equals 8, so we're putting in place of the variable x, and then we can just do the math. So y equals negative 5/8 times 8 minus 25. And then we just have to do the math here, and that's going to be negative 5 minus 25, so that's negative 30. Now keep in mind, when we do this, we're still writing the point of intersection. Our solution is still a point. So we need to write that in the form of an ordered pair, 8, negative 30. And that's your basic substitution. It does get a little bit more complicated than that, but that's the idea. Okay, let's try these. So in this first one here, now we have a line y equals 8. Now we could graph that line y equals 8. And that line would be a horizontal line. And it would intersect this other line somewhere, out here somewhere. But what we know about that point is that when it intersects there, it has to be on this line, and this line right here has a y value of 8. So we don't know the x value, we don't know the y value is 8. All we have to do is take that y equals 8, put it into the equation, the other equation, and then we can solve that. So we'd have 2x plus 8 equals 42. Then we could solve it like regular. Let's see, that's 34. So x equals 17. So the ordered pair, 17, 8. Be sure to not get those backwards, x and y. Now on the second one is a little bit harder, but we're going to use the same idea. So the idea is that we took the value for y in this one, which was 8, and we put it in place of the y in the other equation. So we put 8 in place of that y. So we're going to do the same thing here, except we don't have an actual value for y. We have an expression. But we can take that expression and put that expression in place of the y in the other equation, so that the other equation now looks like this: 2x plus that y is going to become x minus 6, or x plus 6, equals 42. See, the rest of the equation stayed the same. We replaced the y. See, that's what substitution is, replacing that y with something that is equal to that y. The only thing we had that was equal to that y was the x plus 6. So we put the x plus 6 in place of the y. Now this equation we can solve by combining like terms. We don't have to use the distributive property here because that is a plus sign in front of the parentheses. So it's really just 2x plus x plus 6. So that's 3x plus 6. So when we subtract 6, 3x equals 36, and divide by 3 to get x equals 12. Now here's the problem. Well, we don't know what y is. We just found x. We have to find both x and y because we need an ordered pair. So the x is 12. So now we're going to take the 12 and put it back into this first equation so we can find y. So y equals 12 plus 6, so that's 18. So you have to remember to in substitution, use the expression like the x plus 6 here in place of the variable that it is equal to in place of the y in the other equation. When you're done making the substitution, you should have one equation with one variable. It might be a long equation, but it'd still be just one variable in that equation. After you make a substitution, you won't have x's and y's. You'll have all x's or you'll have all y's. And then you'll solve for that variable, take that variable that you found the value for, plug it back in to one of the equations. Actually, it doesn't matter which equation, and you'll be able to find the other variable. Okay, let's try this one. So in this first equation, we have 3x plus 2y equals 36. In the second equation, we have y is the isolated variable. Okay, good. So we have an expression here that is equal to y. So we're going to take that expression and put it in place of the y in the other equation. Now, when we do that, there's a 2 coefficient of y in the first equation. So we have to keep that. So we have now 3x plus 2 times 1/2 x minus 10. That's what we're putting in place of the y, equals 36. So that first equation stayed the same in every way except for we replaced the y with 1/2 x minus 10. Now we have to use the distributive property to solve this one. So 3x plus distribute the 2, so 2 times 1/2 would be 1x minus 20 equals 36. Then we combine like terms, and we can add 20 to both sides. And divide by 4. Okay, now I think 14's right. I just did that division in my head real quick, so I'm not sure. But I'm going to take that x equals 14 and put it into the first equation right here, because this or the second equation, I suppose, because this equation is the easiest one for me to plug x into to find y, because y is the isolated variable. So I need 1/2 times 14 minus 10. So 7 minus 10, so that's -3. So y equals -3. So that would be 14 -3. Now here's the thing. To make sure that this is actually the solution, if I want to check my work, this x and y ordered pair I know works in this equation because this equation is the one that I used when I put 14 in there to find the y of -3. So now I'm going to take this x and y and make sure it works in this equation. So I want to plug it into the other equation just to make sure that I got it right. So that's 3 times 14 plus 2 times -3, and that should equal 36. 3 times 14 is 42. 2 times -3 is -6. 42 plus -6 is 36. Okay. But always plug it back into the other equation to make sure that it works in both, because this solution of the system has to be a solution to both equations. All right, so let's try this one. Now in that first equation, you notice there is a minus sign in front of the y. That's important because that minus sign in front of the y is kind of like minus 1y. And since the other equation has the y isolated, we're going to take that 3x minus 2 and put it in place of the y, but it comes after the minus sign. So it's 5x minus parentheses. Now you can put that 1 in there if you want to. Minus parentheses 3x minus 2, because that's the y value right there, equals 36. If you don't put the 1 in there, it's okay. Just remember to distribute that negative sign. It's like distributing -1. So now we have 5x minus 3x plus 2, because we distribute that minus sign here, which made that minus 3x, and here, which made it minus -2, which is plus 2. So now we have 2x, and we can subtract 2 from both sides. It equals 34, divide by 2 to get x equals 17. So let's take our 17, put it back in this equation over here. So y equals 3 times 17 minus 2, that's 51, I think, minus 2, that should be 49. So our ordered pair would be 17, 49. I really want to check to make sure that that works on our first equation because it doesn't look right to me. But we're going to check it out just to be sure. So that's going to be 5 times 17 minus 49, and that should equal 36. 5 times 17, I think, is 85. 85 minus 49. Oops, that's a 49. 9. Well, 85 minus 50 would be 35, so a minus 49 should be 36. Okay, so that does work. So there is our solution. All right. Now in this one, you'll notice that neither the x nor the y is isolated. In the other problems that we did, the x was isolated or the y was isolated. So you have to choose to isolate one of the variables. Now, choose wisely, because it'll save yourself a lot of time if you do choose wisely. If you don't choose it wisely, you're just making more work for yourself. So the choice you have to make is, which equation and which variable would I rather isolate? Well, here's a y right here with no coefficient attached to it. Well, there is a coefficient, is 1, but really no coefficient attached to it that we have to get rid of if we were solving for that variable. So we're going to solve for this y. Solve for y. To use substitution, you have to isolate either the x or the y in one of the equations first. So if we solve for this y, we subtract 4x from both sides to do that. So now we have y equals negative 4x plus 42. And I suppose you could just write 42 minus 4x. It doesn't matter. We're not graphing it. I didn't ask you the slope and the y-intercept. But now I can take this negative 4x plus 42 and put that in place of the y in the other equation. So now the first equation is going to be 2x plus 3 times negative 4x plus 42 equals 72. Then we can distribute the 3. 3 times negative 4x is negative 12x. 3 times 42, 126. And then we can solve that. Combine like terms, negative 10x. Subtract 126 from both sides. 72 minus 126 is a negative number, so that's going to be negative 54. Divide by negative 10. 5.4. Whoops. I said 5.4 and look what I started the right. Okay, 5.4. Okay, so a decimal, it's okay. You will not have all whole number values. So let's take our 5.4 and put it in place of the x over here. So get y equals -4 times 5.4 plus 42. -4 times 5.4 is going to be -21.6. I think that's right. Plus 42. I'll find out when we check it. Let's see. Let's combine those together. That should be 20.4. 20.4. If I did math right. 20.4. That looks like it should be right. So let's check it. Now to check it, I want to plug it into the first equation here because the second equation is where I figured out that those two numbers go together. Hopefully. So 2 times x, 2 times 5.4, plus 3 times 20.4 should be 72. I don't know, I have my doubts. 2 times 5.4 is 10.8. 3 times 20.4 is going to be 61.2. Add those together, that should be 72 exactly. So our ordered pair, don't forget to write it in ordered pair form, 5.4 for the x and 20.4 for the y. Okay, are you getting the idea? They get a little bit harder. Okay, so remember the last one, we had to choose which equation and which variable we are going to isolate. You have to isolate either x or y, one of them. Choose wisely. Now in that first equation, if you isolate this x here, at the end, you're going to have to divide everything by 3. And one of the things we have to divide by 3 is that 2. And that's going to make a fraction. I don't want to do it. Same thing as if I isolate this y. If I isolate this y, at the end, I have to divide everything by 2, and including that 3, and that's going to be a fraction. And I don't want a fraction if I can avoid it. I'm trying to avoid fractions. If I isolate this x, then I have to divide everything by 9. 84 divided by 9 is not going to be a whole number. So I don't want to do that either. So that gives me this y right here. Now, to isolate this y, I have to divide everything by 3. See, because it's 3y. And 9 is divisible by 3. 84 is also divisible by 3. I know this because 8 plus 4 is 12, and 12 is divisible by 3. So I'm going to isolate this y. So you have to choose. You will not always be isolating y. Sometimes it'll be x. Choose wisely. So to isolate this y, we're going to subtract 9x from both sides. Then we'll have 3y, negative 9x plus 84. Now when you divide by 3, you're dividing everything by 3. Divide this by 3, this by 3, this by 3. Y equals negative, don't forget your negative, 3x plus 84 divided by 3 is 28. I better make sure that's right. That doesn't seem right. Did I make a mistake there? 84 divided by 3 is, in fact, 28, according to my ITA 84. Okay, so we got that. Now that we have isolated the y, we're going to take this expression that is equal to the y, and we're going to take that and put it in place of the y in the other variable, or in the other equation, I mean, like that. So this first equation becomes 3x minus 2 parentheses, because we're taking the y out. Negative 3x plus 28 is going to go into its place. Equals 24. So now when we distribute, you have to be careful to distribute that negative 2. See, this negative 2 gets distributed here. So we have 3x. Negative 2 times negative 3x is going to be positive 6x. Negative 2 times positive 20 is negative 56. Combine like terms, 9x. Add 56 to both sides. 24 plus 56, 80. Oh, it's only 80? That's too bad. All right, so when we divide by 9, we're not going to get a whole number. And I don't want to get a decimal either because that would be 8.99, I believe, repeating, right? Or 8.888. Let me check that out. 80 divided by 9. Yeah, so 8.88888 repeating. I don't want to write that, so I'm just going to leave it 80 over 9. Now, if this is a word problem and that was a dollar and cent amount, then I would, and I would round it off to the nearest penny. But it's not, so I want to get my answer exact. So now I'm going to take the x that I have and put it in place of the x in the first or second equation. Actually, whichever equation you like the best. I like this one. Y equals negative 3 times 80 over 9 plus 28. Okay, negative 3 times 80 over 9 is going to be a negative number. And it's going to be 80 thirds plus 28. No, the hard part is I have to add 28. Let's make that 28. What is 28 times 3? I don't really feel confident to multiply that right now. So 84. I should have known. So that's 84. The reason I'm doing that is because I want this to be negative 80 thirds plus 84 thirds. See, I was getting a common denominator. So that's going to be 4 thirds. Y equals 4 thirds. So my ordered pair should be 80/9 for the x and 4 thirds for the y. Now, do you think it's going to work out when I put it into that first equation? Let's find out. We're going to check it because that seems kind of like a weird answer. So 3 times the x, I'm back in my first equation here, and the x is 80/9 minus 2 times the y, which is 4 thirds. If I do all that math, it should come out to be 24. 3 times 80/9 will be 80 thirds. See, I'm just reducing the 3 and the 9. 2 times 4 thirds, or negative 2 times 4 thirds, is going to be negative 8 thirds. Well, wait, I already had a minus sign there, so hold the boat. See, I already put my minus sign in there. I didn't want to put another one. See, that minus sign takes care of that negative 2. Okay. And that should equal 24 when I'm done. Now, 80 thirds minus 8 thirds, I have a common denominator, so let's subtract those. 80 minus 8 is 72 thirds. Now, 72 thirds should divide correctly to be 24, and it does. If you take 72 divided by 3, you get 24. So there is our ordered pair solution. So, see, if I made this 80/9 into 8.8 repeating, or round it off to 8.9, then I'm going to get a different answer for my y, and then when I plug it back in, it's not going to be correct because I round it off. When you round off numbers, you're changing them. And if you're changing the solution, then it's not going to be correct. All right, now in this one, choose wisely. Which variable will you isolate? Well, I'll give you a second to think about that. Did you choose to isolate this x? I would, because in that one, I'm not going to have to divide by anything. All I have to do is subtract 2y from both sides. And then I have isolated the x. So it's okay to isolate the x. Negative 2y plus 12. And if you want to, you could write 12 minus 2y. Doesn't matter. And since we isolated the x, then we're going to take this and put it in place of the x. So that's going to be 6 times negative 2y plus 12. And then minus 12y equals 24. Now, when you distribute this 6 and you get negative 12y plus 72 minus 12y equals 24. And then you combine like terms. You have a negative 12y here and another negative 12y here. That's negative 24y plus 72. Let's go ahead and subtract that 72 from both sides. 24 minus 72, is that 48? Negative 48? I think it is. And then divide by negative 24. You know, I thought something else was going to happen here. And that's a negative divided by negative, so it's positive 2. So now this time we got the y first. Y is positive 2. To find the x, we're going to take the y value and put it back in place of the y in this equation. So x is going to equal negative 2 times, forgot my negative sign, 2 plus 12. So negative 4 plus 12, 8. Now, when we check that one, we should check it back into this equation, because we used the first equation to find 8. So now let's see if it works in the second equation. So 6 times 8, for 6 times x minus 12y, and y is positive 2, should equal 24. 6 times 8 is 48, minus 12 times 2 is minus 24. And I'm pretty sure that does equal 24, so it's good. See, it only takes a second to check your work. So check your work. Now comes the fun part. So we can apply what we have learned to solve some word problems. Okay, let's take a look. A taxi company charges $2.80 for the first mile and $1.60 for each additional mile. B taxi company, oh, I get it. A taxi company and B taxi company. Okay. Charges $3.20 for the first mile and only $1.50 for each additional mile. After how many miles will each taxi cost the same? Okay. Now, we're looking for, it tells us we have information here. Oh, okay, good. Let X represent the number of miles. Okay, I want to make an adjustment here. Let's make X represent the number of additional miles. The reason I want to make X the number of additional miles is because this $1.60 for taxi company A is for each additional mile. And for the B taxi company, this $1.50 is for each additional mile. That way we don't have to do anything fancy. Okay? So let's write an equation for taxi company A. Okay. And we're going to write an equation to represent the total cost. Okay, so the cost, which is y, will equal, $2.80 for the first, okay, so we have to have that $2.80. I'm not worried about slope-intercept form right now. It's just getting the equation. $2.80 for the first mile. I don't think we have to multiply that by anything because the first mile is always just going to be 1 mile. No changing that. Okay? That's like the beginning cost. That seems like if we were graphing, that would be our y-intercept. And that's our plus sign. That's $1.60 for each additional mile. Now that $1.60 is going to be changing depending on how many miles you go. And since X is the number of additional miles, that's $1.60 for each additional mile times the number of additional miles. So that's the A taxi company cost, $2.80 for the first mile, $1.60 for each additional mile. The B taxi company, the cost is $3.20 for the first mile. Again, that's not changing. It's $3.20 for the first mile. And that's our plus sign. $1.50 for each additional mile. $1.50 for each additional mile times the number of additional miles. X is the number of additional miles. Now, in this one, the question is, after how many miles will each taxi cost the same? Okay, for them to cost the same, that means this cost has to equal this cost. Or if you think about it in terms of a system of equations, then, remember on the last view I said you have to isolate either x or y and then take that expression and put it into the other equation. Okay, so let's just pretend that we isolated this y right here. Okay, so we're going to take that expression and put it in place of the other y. Think about what that's going to look like. That's going to look like 3.20 plus $1.50x equals 2.80 plus $1.60x. It looks like we're setting the two equations equal to each other, and we kind of are, but we're really using substitution. But that's what it looks like, because we wrote an expression for the cost for each taxi company, and the cost of A taxi company is equal to the cost of the B taxi company after so many additional miles. All right, so there's our equation, there's our equal sign. So we've already done the substitution. Let us solve this equation with x on both sides of the equal sign. I'm going to subtract $1.50x from both sides. And at the same time, I'm going to do two things at the same time. I'm going to go ahead and subtract $2.80. Why? My hand is not writing the numbers that are coming out of my mouth. I'm going to go ahead and subtract $2.80 from both sides, because that way I can do two things at once. So when I subtract these, that should be 40 cents. And these cancel out, and these cancel out. And so when I subtract these, I should get 10 cents times x. So now let's divide by 0.10 to get x equals 4. So that means, remember, x is the number of additional miles. That's important. So that's 4 additional miles. Which means a total of 5 miles, because the first mile was like the constant. It was already taken care of by the $2.80 or $3.20. But the x was multiplied by the 160 or the 150, and that was 4 additional miles there. Now, you want to check your answer? You can just take 4 and put it into this equation in place of the x and do the math. And take 4 and put it into this equation, do the math, and they should come out to be the same. I'll let you do that. Okay, let's try this one. This is a common problem. We've had problems like this before, but we've never solved them in this same way. Really, I guess. Maybe we have. But anyway, let's try this one. This is the movie ticket problem. An adult ticket to a school play. Oh, it's a school play problem. Costs $5. Student ticket costs $3. A total of $460 was collected from the sale of 120 tickets. How many student tickets were purchased and how many adult tickets were purchased? Let X be the number of adult tickets and Y be the number of student tickets. Okay. So we have two things that we know here. One thing is about the total cost or the total amount of money collected, because Adult tickets cost $5. Student tickets cost $3. The total amount of money collected was $460. So that's one thing. We should be able to write an equation for just the money. Okay? For just the money, we have $5 for each adult ticket times the number of adult tickets. Number X is the number of adult tickets. Added to $3 for each child ticket times the number of child tickets. That should be the total amount of money because, see, that's $5 and $3 multiplied by the correct number of tickets would give you the total number of dollars, $460. Now, the other thing we know is about the total number of tickets. They sold 120 tickets. Now, selling 120 tickets should lead us to write another equation. Keep in mind, X is the number of adult tickets and Y is the number of student tickets. And those numbers of tickets should add up to the total number of 120 tickets, which is just X plus Y equals 120. So sometimes this second equation here is the hardest one to get because everybody's focused on the more difficult thing of the money, and most students are able to write that first equation easily. But the second equation is kind of like almost too obvious. 120 tickets, X plus Y equals 120. All right, now if we're going to solve this using substitution, we have to isolate either X or Y. I would choose the second equation and isolate either the X or the Y. It doesn't really matter because they would both be pretty easy to isolate. Since I like isolating Y better, I'm going to isolate the Y. So Y equals, I'm going to subtract X from both sides. I'm going to just write 120 minus X. I don't have to put it in slope-intercept form. I'm not graphing it. I didn't ask you the slope or the y-intercept. I'm just writing the equation. So now I can take this 120 minus X, that's the expression that's equal to Y, and put that in place of the Y in the other equation right there. So now that first equation is going to be 5X plus 3 times 120 minus X equals 460. So I have to do a little bit of distributing and combining like terms to solve this. So distribute to 3, 5X plus 360 minus 3X. Let's combine the 5X and the negative 3X, that's 2X. Let's subtract 360 from both sides. So I have 100, and I can divide by 2 to get X equals 50. Okay, the easiest equation to plug that into to find the Y is X plus Y equals 120. So 50 plus Y equals 120. So Y equals 70. Now, in this case, we don't really have to write it as an ordered pair, but you do want to write it in a way that I understand what the X and Y represent. So that would be 50, let's see, X was the number of adult tickets. So 50 adult tickets. They're not interchangeable. And 70 student tickets. Oops, student tickets. So if you want to see if that's correct, all you have to do is take your 50 adult tickets and your 70 student tickets and put them in that first equation to see if it comes out to be $460. That way you can check it. All right, let's try one more. The Nut Shop. Now, if you've never been to Columbus, Ohio, there is such a thing called the Nut Shop. It's on the corner of Gay and High. The Nut Shop sells roasted peanuts for $4.25 per pound and cashews for $6.50 per pound. A certain customer wants to order a mixture of peanuts and cashews but wants to pay only $5 a pound. Okay, the total weight of the order is supposed to be 20 pounds. How many pounds of peanuts and how many pounds of cashews should be in the mixture? Okay, so the question is how many pounds of peanuts? That's going to be one of our variables. Now, we don't have to use X and Y. So far, in every single problem, we've used X and Y, but you don't have to. You could leave like the number of pounds of peanuts as P. And then C could equal the number of pounds of cashews. Now, some people just write P equals peanuts and C equals cashews. But see, I want to make sure that you understand that P is actually the number of pounds. Because if you don't, if you just write P equals peanuts and C equals cashews, then you might think that it's the cost for the peanuts instead of the pounds of peanuts. Okay, but P and C are the pounds. The reason that's important is because one of the things we have to write an equation about is the total weight of the order is 20 pounds. And if we know that P and C represent pounds, then when we mix them all together, that would be P plus C. Pounds of peanuts plus pounds of cashews should equal 20 pounds. There's one of our equations. Now, the other equation is all about the money. See, it's just like the ticket problem. The peanuts are $4.25 per pound. Okay, so the P is the pounds of peanuts, $4.25 per pound for peanuts times the number of pounds of peanuts. Okay, for the cost. For the cashews, $6.50 per pound. So $6.50 per pound times C, the number of pounds. Okay, now this should be the total amount of money, just like in the ticket problem that we did last. That should be the total amount of money. Now, in this problem, we don't have the total amount of money. But at the end, we only want to pay $5 per pound. Now, you can't really just say that this equals $5. $5 is not the total amount of money. It's $5 per pound, but there's 20 pounds. So that's $5 per pound times 20. See, we multiplied the P times the dollars per pound. We multiplied the C times the dollars per pound. So we have to multiply the 20 times the dollars per pound. Okay. So there are our two equations. Whoops. So how should we proceed to solve? Oh, yes, we're going to use substitution. Now, in this case, instead of solving for x or y, we have to solve for one of the variables, p or c. So I'm going to solve for p here just because it's the front of this little equation that we have for p plus c equals 20. And I'm going to isolate that p. Solve for p. If I do that, all I have to do is subtract c from both sides so that I have p equals 20 minus c. So now I have an expression for the p, 20 minus c, and I can put that expression in place of the p. See, if you isolate the p, you're going to replace the p. If I would have isolated the c, I would replace the c. So you have to be careful about that. If you make the correct substitution, your resulting equation will just have one variable. So in place of this p, I'm putting 20 minus c. So that's 4.25. Did I get that number correct? Times 20 minus c plus 650 c, $6.50 c, equals 5 times 20. I'm going to go ahead and multiply that together. 100. So use the distributive property. 4.25 times 20. Is that 85? Minus 4.25c. If that's not 85, someone tell me. Don't forget to put the c on that. Plus 650c equals 100. Okay, let's combine these like terms. Now, these like terms, remember that's a negative 4.25c. So now I have 85. 650 minus 425, 225 plus 2.25. If I subtract wrong, I know you'll tell me. Equals 100. And then I could subtract 85 from both sides. So now I have 2.25c equals 15. I'm going to have to use my calculator to divide this, and we're going to divide by 2.25. Divided by 2.25. Oh, I got 6.6 repeating. Okay, now this is interesting. So I'm going to make that 6 2/3 because I don't like to use repeating decimals. And remember, C is the number of pounds of cashews. So that's 6 2/3 pounds of cashews. Okay. And since I have P plus C equals 20, right? Then I can just take 20 minus 6 2/3 to get 13 1/3. So P would equal 13 1/3. Those should add up to 20, right? Pounds of peanuts. Okay. Now, if you want to see if that's right, you can take those pounds of cashews and those pounds of peanuts and plug them into the cost equation here. The reason you want to plug them into the cost equation is because I found this 13 1/3 pounds of peanuts by using the number of pounds equation, P plus C equals 20. But it's got to work in both. Please write out what your answers represent. Don't just say P equals 13 1/3 and C equals 6 2/3. Write pounds of cashews and pounds of peanuts for those appropriate answers. Okay, so there is a little bit of substitution. Hopefully it brings back fond memories of things that you might have learned somewhere in the distant past, and you'll remember how to do all that.